Awesome. Welcome, everyone. This is another fun adventure with Deep Learning Adventures, fun, engaging community where we talk about data science, machine learning, and specifically deep learning topics. I'm George, and I'm joined by my great friends and colleagues, David and Robert, and great friends here joining us tonight, as well as lots of great friends from all around the world online. So welcome, and just to keep things simple, we've been embarked on this AWS machine learning certification journey for last year, actually. And in the past session, if you go to our playlist, we covered a little bit more on the journey experience side, as well as what resources we used. More of like a side project was us adding lists or URLs to a bookmark, and this is what we're going to talk a little bit about today. And towards the end, I'm also going to talk about something called topic modeling, which I think is kind of related to what I'm trying to do here, but more in the automated way. So stay tuned for that. Okay, so let's see what is the best way to do this. Let me share my screen. Can you see my desktop? Awesome, cool. So
Looks
yeah,
good.
You can find us on our Meetup page. We have a link for the presentation, the links for the different AWS certifications, Slack, and all that fun stuff. And if this is new to you, if you go to Amazon.com, AWS Amazon.com certification, you can see a little bit the structure of their certification programs. So they have an entry-level one, which we took as a community called Cloud Practitioner. That really set the tone for the terminology, the basic foundations and pillars of cloud services, compute, storage, networking, security, AI/ML. And then you can, if you want, you can focus on specific fields at more advanced levels. So there's an associate level for solution architect, for example, if you want to design systems. If you want more on the developer side, there's one specifically for developers. And more on the operational side, something for system ops. If you want to take it one notch higher, you have the professional level ones for solution architect and DevOps. But we jumped ships. We went all the way from Cloud Practitioner to the machine learning specialty. And we basically prepared for it. It took us a while, but we passed it. And we learned a lot, not only about machine learning, which we think as a community pretty much own and master at this point, but we learned a lot on how this is executed in AWS and how do you operationalize, how to use the many features that SageMaker has, and how do you deploy it, and so forth. So we put together a playlist on YouTube. If you want to check it out, we have one for Cloud Practitioner as well as the machine learning specialty. And this third session is really that wrap-up session, which we're going to go over. Also have a slide together. I'm not going to go through it here, but we've gone through it again. We have links and resources on some important useful information out there, some free and paid resources we used, many other recommendations that we came across, and new features as we're doing this, right? It took us about a year. New features showed up, especially on the AWS side. So for example, the AWS machine learning blog, a dedicated website for the specialty exam, and so forth. And we also shared our experience online and in person. For this session, I'm not going to bore you too much, but I added in these slides all the links. There's about 170, 180 of them. I'm going to sample some of them. Really, the goal is here for me to identify some clusters of information. And if I was doing this again, how would I approach it? So no need to look at something here. I have a tab specifically open to bookmarks, and I'll just sample from there. Any questions, comments before we start? So I'm just going to give an overview a little bit before I just sample a few. Okay. So really, many of these bookmarks started by us just Googling, or coming across resources, learning resources, as well as that WizLabs paid resource where once you come across a question and you select your answer, there are explanations about it as well as references. So a lot of this came from that references in WizLabs. So just wanted to mention that. So for me, I'm going to do a scroll down just for you to see a little bit of maybe from the logos, we can tell what I'm looking at. But as you can see in the beginning, some Kaggle resources, several scikit-learn resources. I'm just mentioning the source for now. Some dedicated resources from machinelearning.com, machinelearningmastery.com, really good resource. Some from TensorFlow, some from YouTube, and then a lot from documentation from specific Amazon Web Services SageMaker features. Every now and then some papers might show up, but not a lot. Really, the majority of them is from AWS. Let me zoom a little bit more so it's easier to see. Resources. Some notebooks are out there. Amazon Web Services has some really good GitHub accounts for different products, so I came across those, as well as XGBoost is extensively used for this specialization. So if you really want to look at our man page, recommendation page, I highly recommend it. Okay, all right, so I'm going to start from the top and just really going to set the tone a little bit about the cluster, right? So we have the scikit-learn information here, and really the most important ones are from the basic data transformation, data engineering side, as I call them. This would be more on the data engineering side of the exam. So anywhere from feature selection, from pipelines, if you haven't used them, if you haven't come across them, I highly recommend them. Column transformers, nice and efficient way to do those. So I'm just gonna sample some of them here. Okay, I thought I could open this. Okay, there you go. So yeah, really good resources. If you want to take a look, I highly recommend those. It'd be nice to see actually how they're used in code, just to get an idea of how to, for example, apply specific transformation to string type fields or a specific transformation to a specific field, like numerical features. Okay, imputation came up a lot during this presentation. So simple imputer and other imputation methods are there. There are machine learning imputation methods as well that you can look into, deep learning ones. Those are really interesting as well. And then I came across this comparison, right? So you're learning different imputation methods. It'd be nice if you can compare them. And I think I came across this paper from, I think it's from a bio background, 2015. Okay. So they have different comparison methods here, anywhere from mean imputation, k-nearest neighbors, SVD, mice, hold on, there, this here, yeah. Fuzzy k-means, single variable decomposition, Bayes in principal component, and multiple imputations by chain equation. So I think this was a good comparison. If I remember correctly, let me see here. Here's the iris data set, and they compared how the imputation schemes work on different metrics. I think mice might have performed a little better on more of them, like on the larger data sets. But I find this paper interesting. Okay, so then yeah, this is me looking more into mice. Outliers, pre-processing. So yeah, this is more the data engineering side, and I found that interesting. This was, let me remember what this was, time series related, or we talk a little bit about live stream data, right? So I think some questions are there on streaming services, and there were some questions in terms of sliding windows, tumbling windows, and there was another term. So just coming across those and having like a visualization of what that means what's useful for me. So for example, in sliding windows, you have overlap, right? In tumbling, you don't have any overlaps. It's distinct chunks of data as they come in. Okay. Let me close this. XGBoost came up a lot, so if you haven't used it before, definitely check it out. Their website has lots of good resources, as well as examples on how to use it for different reasons. I felt like when I was doing the preparation, a lot of the questions came around these hyperparameters, like what did you use? So it's used for both for classification and regression problems. So what objective are you trying to aim for here? So if you're using regression, you can do squared error or squared log error, doing classification, logistic, and different loss functions. So getting to know a little bit better the hyperparameters really helped us a lot. And then if you're evaluating, let's say, a validation set against a metric, what metric would you use? Similar to what we've seen in TensorFlow. Okay, that was a good resource. Feel free to chat or chime in if something piques your interest. Then I think I use a lot of resources from Machine Learning Mastery, really good websites. One of them was this multinomial. When you have more than 2 classes, right? So when you have more than 2 classes, how do you build a simple multinomial regression problem? So this was a good one. Let's see if there's any visualization here that we can look at. Yeah. And I think this is a different run. So accuracy scores for each configuration, I think using different hyperparameter tuning for what model do we use here for logistic regression? Yeah. And k-fold validation, that came out across a lot as well. So you can do stratified k-fold, simple k-fold, depending on if you want that representativeness of classes in your data sets. Okay. One versus rest versus one versus other is another technique that you can use for multi-class classification. So there's that aspect of it. Let me see. Categorical, sparse categorical. We've come across this in our TensorFlow. Oh yeah, I want to share a little bit more about this resource, this company that I found their resource is really useful. So I think they're specialized in NLP. But they have really good, nice tutorials on YouTube. Specifically, there's machine learning from scratch, which I really like. So you really implement things in Python, and you go from things like k-nearest neighbors, linear and logistic regression, decision trees, random forest, naive Bayes, PCA, like perceptron we've done several years ago from scratch, SVM and k-means. But I really like their approach. It starts from very basic. I'm not gonna play this now, but you start with building classes, building methods. It was a really good resource for me, so I recommend it. Okay, so that's more of the scikit-learn / machine learning mastery and some YouTube resources. Then during this journey, you mentioned this as well, David, but the formats are very important from AWS perspective. So anything, I think this came more on the preparation side. I don't remember. There's no code in the exam itself, right? So you're not going to see anything like this, but you might see something of maybe score, or if a score is a list, things like that. But I don't think you're actually going to see a JSON object as a question in your exam. Imbalanced data came out a lot. So familiarizing yourself with how do you deal with balanced and imbalanced data set. I think is a really good approach. So I think I have several resources on that. Hyperparameter tuning jobs came out as well in this preparation. So these are basically configurations you do in JSON within SageMaker, and you get to specify a name for the hyperparameter tuning job, the metric, and then for categorical parameters, the name of it, the values, continuous, integer ones, how many you can run in parallel, what kind of strategy you can do, when would you stop. So there's a lot of room for experimentation here. So yeah, lots of that. Step functions is when you want to automate this a little bit. So it's more on the infrastructure side. Spark came out a little bit in the preparation. I don't remember seeing any Spark specific. Maybe PySpark came out once in the exam. So if you want to check that out as well. Then
is Amazon mostly presenting Spark as an option for data engineering for feeding into SageMaker?
Yeah, more on that perspective of like how do you efficiently bring in data from, let's say, an external data source into SageMaker, yeah. And how do you transform it before you store it to S3? Really, when you say SageMaker, you really mean how do you store it to S3? So SageMaker is configured and optimized to read from S3 really well.
So do you need to know resilient data sets, or just Parquet would be sufficient?
I think Parquet is heavily used. Yeah, no other formats. But really, yeah, the goal is not to focus on Spark or anything like that. Just how do you use it as a data transformation pipeline, I guess. Okay. So each cloud vendor, right, has APIs for this common AI tasks. So I think that might come out in the exam. So one of them is this one, recognition that analyzes and detects faces or face attributes. You can even compare things or even detect them in a video. So that's good to know what APIs are offered as services for someone who doesn't need to know all the back end, how that works. Smoke came up a lot as a way to solve the imbalance problem. So this is a resource that I came across of how did you do that and what does that mean. If you want to check that out. Then Kinesis came up several times, streaming data, more on the how do you satisfy a business need, right? So if your data is coming live and if your analysis needs to be able to catch up with it, then you need some kind of streaming infrastructure. Formatting is there. Linear learner is one of the built-in algorithms that AWS has. Data pipeline is one of their services. Data migration services when you migrate data from one database to the other, or from one schema to the other, or let's say from Oracle to, say, MySQL. XGBoost is there. Encoding, k-means. There is also a labeling feature within SageMaker ground truth. So you can choose to automate the data labeling process. So yeah, let's say on unlabeled images. So you can randomly send them to annotators or have a model that is trained on your data, and once it's confident enough, he can label the rest of them. So there are different approaches here. And I think you can set thresholds. So if your confidence is low enough, I think you can say, let this be annotated by human laborers. IoT analytics came out as well. It's like this usually goes with streaming services like Kinesis. XGBoost, we mentioned that multiple times. Glue came up several times, and I didn't know that Glue has some nice features, including this ML transform to find matching records in your data set. So let's say you have emails or names or street addresses, whatever that might be, and you want to kind of dedupe them. So there's a nice feature within Glue where you can find matches that are very, very similar. So that could be product, places, customers, and so forth. I think CloudWatch has some nice capabilities in terms of monitoring your jobs and training. So you can see things like utilization, GPU. Not only that, but based on what your evaluation metrics are. Let's say I'm interested in accuracy. You can also graph that. So in this case, I'm graphing validation accuracy, or this snapshot, throughput, training accuracy, cross entropy loss, validation, cross entropy loss, training, validation. So think of it as TensorBoard plus infrastructure where the code is running, kind of monitoring platform. Encryption definitely comes up a lot, especially within S3. Oh, this was a good one. Factorization machines. How do you use them? A little bit more about factorization. How do you use them in recommendation systems? They have a nice block here. How do you do that? And there's a service that actually can use within AWS.
Amazon personalized.
Yeah. Okay. Then if you want to learn more a little bit about finding similar or recommending things based on a user or based on similar products, there's two philosophies of thoughts there. So content-based, recommend items similar to what the user likes, versus collaborative, where you look at similarities between users. So one looking at items, one is looking at more the user perspective. Okay. This was interesting to me. I'm going to open this resources. Bias, fairness, explainability. I hadn't come across them within AWS. We've seen them from other third-party applications or libraries. So it was interesting to me to see that SageMaker has within it detecting pre-training data bias. So maybe you have an imbalanced data set, but to me, that was interesting on how to use this. And there's a specific service called Clarify that helps you detect bias during your model training. Yeah, there's an example here. Let me see if I remember this. Oh yeah, this is the outcome. Like you have a structured data set and you're trying to predict if an income of an individual is less or equal than 50K or more than 50K based on these features. Let's say age, work class, education, occupation, and all that. And I think, let's see, they have a nice structure approach on how to detect bias here. So yeah, maybe by gender, maybe by, let's see, Yeah, how does it look by gender? And a few other metrics, but I found this very interesting approach. Yep, clarifies the service. Maze. Looks like the page doesn't exist. Okay. And also came across a paper how to use this in finance. I think it was mentioned one of the resources. But yeah, that was a good cluster. Like, it was new to me. Okay, moving on. S3 endpoints. Data quality. Oh yeah, let me open this. So this is basically, to me, when you're in pandas and you're doing some kind of df data frame.info or describe or similarity, pairwise similarity of features. These are features that you can do within SageMaker itself. So you can do things like, give me a summary of my statistics, how many features I have, how many records I have, how many missing values I have, how many duplicate rows I have, by feature type, how many are numeric, categorical, text, date time, binary, vector, and all that. You get some outlier information, target leakage in the sense that maybe your target is correlated with one of the features highly, or maybe you have highly correlation. So target column, you get a nice report of the values, and then a histogram of the target column. And then what else? I think it also runs a tiny bit of a quick model. Yeah, this was cool to me. Does it say an XGBoost? Yeah, it trains an XGBoost on this classification, let's say. And it gives you just a benchmark so that if you want to try your own algorithms on top of this, you can check it out. But it does that out of the box, gives you a confusion matrix, and how does it score against different metrics, which looks like, yeah. Feature summary. If this is an explainable model, yeah, which feature was important, how predicted power, and yeah, feature importance is there. So yeah, like basically a quick and simple way to get started with your model and data. Found that very interesting. And this is insights. Okay. The notebooks were interesting. Let's see if I can pick one here. Ground truth is for labeling. Model evaluation. Let's look at ground truth first. So there's the whole code and the whole preparing the data, and I use ground truth here. And I think you can also have like human in the loop if you want to do this. So there will be a graph here or something in the end. Oh, that's the code. Okay. And then this is processing model evaluation. This one on the infrastructure side. Okay, let's see what else. Fraud detection. Okay. Yeah, this. Trying to find if anything stuck out to me. Yeah, so you see a lot of resources come from AWS itself, which is normal. And every now and then some other external resources as well. Okay. I'm gonna stop sharing here. Comments, thoughts before we switch gears, but there's a lot of information here. Again, this is all in this slides here. And if something is of interest, feel free to check it out. Okay. Cool.
George, just to confirm, most of these are like blogs or documentation, text-based, and there's a few, I think I saw a few that were some video series in there. Or most of them aren't video, right? Most of them are just text or examples kind of things.
Yeah, it's other documentation, maybe a blog on how do you use this. And there's one YouTube series that I like because it implemented things from scratch.
Right.
But I've also come across another YouTube playlist that I recommended for this exam that I mentioned before. It was
The deep dive.
the deep dive. Yeah, this one here. This one.
Yeah.
So if you want to take a look at this, this is definitely a highly recommended one.
I found that one to be good. It's a little bit dated in terms of the interface they present, but the overall it's very good, I think.
It says last updated September 2022. Yeah, maybe.
It could be the first videos are
Oh
older
yeah,
than.
first videos. Yeah, 3 years ago. I agree with you. Yeah, and then
Yeah.
last few ones. Oh, they added a few 5 months ago. Okay, 7 months ago. So I haven't
Yeah.
seen the last 3 they've added.
You think
Right.
the content from those older ones is still relevant? It's just the interface is.
I think for the most part, there's a few things that are different. Like they're showing you how to set up things and you no longer do it that way. There's some differences that have, some updates to the system that have changed, but it's pretty good.
Yeah.
And like George said, as it goes, it gets better and better. So.
Right. The architectural diagrams were nice. Yeah, and then I like it. Yeah, I mean the UI UX might be different when you log in, but still the general message is true, I think, on the approach. So this is a good resource. Okay. Cool. Then I wanted to switch gears and talk about another resource that I came across while doing this. I was watching this YouTube video from PyData 2022, and Jamar Alamar, was it Alamar? So the guy who wrote really good documentation on transformers, Jay Alamar, I think. Yeah. So he did a talk on it, and I think he covered this topic a little bit. But I found it interesting. This is developed by, not him, this is developed by his name Martin. Let's see if I can find his page. Station Martin. I found his background. I think he was a psychologist turned data scientist. Yeah, psychologist turned data scientist, special about using AI to make the world a slightly better place. And he has like different, has a blog post, but this is one portfolio. And he also has a really good recommendations, like how to build a data science portfolio. Things about notebooks. I like this portfolio. One of the topics he built is this one per topic, which I'm briefly gonna talk about and why I think it's related to this. So think of it as, so this isn't the idea of topic modeling. When you have multiple documents and you're trying to get an idea of what are the important topics that are mentioned there, right? Let's say you have hundreds and hundreds of news articles or blog posts or bookmarks. And you're trying to get, okay, what are the topics that are mentioned here? So this one uses transformers and a modified version of TF-IDF to create these clusters. So it supports multiple versions of topic modeling. I'm not familiar with all of them. So if you want to check it out, this is it, but you need to install it. And I wanted to give you a quick overview of what this is and how you do it. But I think this 30-second video does a great job. There's no audio, so if you don't mind, I'm just going to play it. But what it does is I'm going to pause it as needed. So it has multiple layers. This is like the Lego approach that they have. So you can use, for example, transformers to create your embeddings. You can use things like specialized transformer models. You can use things like Spacey. And this is going from like raw data to embeddings, right? So from text to embeddings, or from let's say language to embeddings, or whatever your data is. Then these embeddings, you have lots of data, you need somehow to reduce the dimensionality of it. So you use different dimensionality reduction techniques like PCA, UMAP, SVD. Then you want to cluster them, right? So you have your data, you want to cluster them, k-means, DB scan, all that. Then you want to tokenize it. And then you want to apply some kind of weight on different tokens. And then you want to optionally want to do like topic representation. So this diagram is like flexible. You can like pick and choose how you do this, and it will support it. So I found this Lego approach really, really cool. You can also do things in topic modeling. Maybe someone who's more familiar with it can understand this better, but yeah, you can do terms, similarity, topics over time, topics for class, and all that. So I find it interesting. So I'll share with you a very quick overview of how this is and how I try to approach it for my bookmarks, and what are other approaches that you can do. But there's a GitHub here, and the GitHub has what I like, collabs, right? So it has like, how do you do topic modeling with BERT, or how do you do embeddings? How do you customize it? How do you dynamic, or how do you look at abstracts from archive? I think this notebook, I'm not going to go line by line. I'm just going to give you the overview of what I think was useful. So this is running on Colab. I'm going to zoom in a little bit more so you can see. So you need to install BERT topic, and I think you need to restart the runtime after this. It's using from sklearn datasets this a newsgroup dataset, and you're removing the headers, the footers, the quotes, and you're just getting the data. This to me is very important, and you'll see when I try to use this what happens. So there's about 18,000 posts here. So we're getting that in this docs variable. We're importing BERT topic. You can use multiple languages, multilingual here. In this case, we're using English. There's a notion here if you want to calculate probabilities. This might be a little bit slow if you have more than 100K documents. In this case, we have them equal to true. We don't have that many. And then we transform our documents, and let's see what we come up with. So we're going to come up with is a default topic where nothing else fitted, like a else topic. So ignore that, -1. And topic 0 had 800 documents related around, let's say, religion, 700 documents around space, 600 documents around hockey, 600 documents around baseball. These are the top 5. There's more than that. Then if you want to explore the topic 0 more, you can get the main words or associated with it, as well as more attributes. So if you want to see the size of each topic, probabilities, their embeddings, and so forth. So we got this, but then how do you visualize, right? The goal is to have some kind of visual representation of these different topics and how do they relate to each other. So there's a visualize topics feature here, which I find very interesting, and it's interactive, right? So this is after applying dimensionality reduction. So first some around soccer, around some colors, some that might not make much sense. Aid here, encryption, and you can zoom in. Let's say I'm interested in this cluster here. Let's say bike, boxer, bikes, dog, okay. Cars, I guess, or outdoors, taxes, secretary, okay. Maybe you can zoom in more here, see what's happening. Cryptography is the big one. Encryption. So I see there's a big one. Topic 16 has about 600 documents related to this keyword. And then there's a subset of it with just 23 on specific, maybe terminology within cryptography. I find that interesting. Can go back home and let's see. There's 120 topics here. And if you slide this, just highlights by number. Then yeah, probabilities. If you're looking at maybe the first or second topic, you can look at things like hierarchy. So how do they relate? If there's any kind of relationship between them, how do you cluster them? And how do you visualize them? You know, top 5 words for each topic. And then what is a similarity matrix? This was interesting to me, right? So you have so many. If you want to do some kind of similarity between topic X and topic Y, what is that similarity score? And so the darker blue, the more similarity there is. So you see different clusters, especially here. So car engine diesel and car gear is highly correlated. You know, very interesting. Let's find another one. OS, Unix, and Mac highly correlated. Okay, tech related. Science is astrophysics. Okay. Windows. So these are from news posts, right? So the content could be really diverse. Then they have, as you consider more and more words, what happened to the importance score. So the more topics you add to it, the least they contribute, you know. So the more specific, I guess, you get in your word description, the less important it becomes. Okay. Then where do you use this, right? So you did this. What I find is interesting is you can use it in some kind of search engine, right? So imagine if you build this and you have this 18,000 posts and you're interested in a keyword or you're interested in, let's say, recipes or whatever. So in this case, you can find topics related to this keyword vehicle and give it the top 5, and it will give you those topics. Not only that, but you can also find posts within that topic that are most relevant to this embedding of vehicle. I find that very interesting, right? So you embed all your documents in this high dimensional space, then you have your input, you embed that, and you see which one is closest to it. Yeah, this is a good resource. Check it out per topic. I found this really good resource. Now, questions, yeah?
Can you add bigrams and trigrams here? Do you know? Did you check it out?
Yes, there is an update. Let's see. There's an update feature, yeah, where you can do n-grams. So let's say you want to consider more than words. You want to consider 2 words or different n-gram ranges. There's an option to do that as well, Maya. Yeah, I remember this.
Looked like you had some outputs down at the bottom that were bigrams, no?
Well, maybe this was for like 1 or 2 words. Let's see. Yeah, previous
The dealer, previous owner.
Yeah, so this is after you updated the model, I guess. So in the beginning, it was only for 1 word, and then there's an update model where you can do n-grams. So let's say I want to consider 3-word combos. Yeah, see, this update is right here towards the end. So whatever I showed in the past, it was just for 1 word.
I didn't understand. There are different methods, or it is the same methods? Because what I studied, there was like 3 different methods.
Yeah.
Like hierarchical was separate from others, and LDA with a picture was another one.
Okay. So they have some kind of hierarchical representation feature. This one here. Is that similar to what you have in mind, or is it different? So this is to understand.
It looks like they combined it because they said that it is hierarchy for created topics.
Yeah, so they're creating clusters and they're visualizing how they relate to one another.
Yes.
Not exactly how this is running the backend. Yeah, feel free to check it out. So my goal was, okay, you do this for the 18,000 posts. Can I do it for my bookmarks? So let's see, I really copied this. I didn't change much. Instead of the data, I used. So first of all, a few things. I imported my bookmarks as a Excel. And this is my data frame, has a title and a URL. And I needed to parse, I need to read that input right from the web, because I don't have the website. I just have the title, and the title is usually short, doesn't tell me much, but there's a whole website here. So a quick method to use Beautiful Soup here, requests. And then within each page, you have like headers, input, meta information. So there's like a blacklist block here where you extract it when you do your so you get the data, you pass it through Beautiful Soup, which is a parsing, HTML parsing library in Python, and then you give the output. So I just want to show you how does that output go if I just do it for the first URL. And that one is just a Wikipedia article, might be hard to read, but basically it talks a lot about machine learning. But the most important thing is you need to realize it's HTML, right? So you're going to get a lot of HTML related code and links. This is the main content. I'm like, okay, this is great. But then towards the end, there's all the citations that you see in Wikipedia. You know, they're here, and probably different languages and different templates and all that. So I did that for all my bookmarks, 160 something, took about a minute and a half. I looked at all of them. Some of them were built in, and that's interesting. If you look at the Kaggle one, if you don't mind me scrolling up. If you look at the Kaggle one, this is not complete. I was hoping I'd get the code for this, right? So if you look at views, page source, it's built within JavaScript. Like there's no there's no code here. So you really have to click somewhere. Like that was interesting to me. So not user or at least Beautiful Soup friendly. This page. Some other pages were like that as well. Okay, so I did this. I got my documents. I ran it through per topic. And then I got a bunch of things that to me didn't make a lot of sense. So more like common words approach, you know, like V2, 4 data. I get AWS there for sure, Amazon. But yeah, for the first topic, I got a lot of like repeated words. I'm like, this doesn't sound right. Looks like I need to remove subwords.
Seems like given this data set, the word data is a stop word now.
Right, data, yeah. We, you, your, yeah, like is. It's like offering services. And then I looked at yeah, a representative document for topic 0, and this was it. KMS, dedicated. So the 2, 4 data, right? Apparently those keywords apply or appear multiple times here. But also a lot of like non-human user-friendly, right? Things like that I think skewed it a lot. So yeah, when I look at mine, like, didn't make much sense from here. Oh, this one made sense to me, but still I'd like to drill down on this more. So yeah, the clustering topics, similarity. And then, so I understood the the issues here. I'm like, okay, are there any other approaches we can do? And then at the end of this notebook, I tried more like traditional approaches, like LDA. And this is used for doing as well, something similar to that. So I passed my, I vectorized or I embedded my documents here. And then there's a step here where you get to define how many components you want, pass them to LDA, and then you sort them, and this is what you get. So topic 0 by popularity is the margin, the width, the padding, the height. We did all, all the HTML thing that you don't see as a user, but the machine is like, yeah, you talk a lot about the HTML. I'm like, not really. Dynamic frame. Okay, machine learning mastery came. I'm like, finally, some connection security, compression, fire hose. Okay, this is good. Open search. So this is more like on the search side. Streams, shard, yes, fire hose. This is perfect. To me, this is like, yes, you found a really good topic on streaming and fire hose and sharding and all that. I don't know if, faces, maybe recognition, yeah. MySQL. This is for hyperparameter tuning. This is instance type. I have no idea what this is. Looks like codes. Clarify. Yeah, so some of them I recognize, some of them I'm like, okay, this is just HTML. This should have been number 1 in the world. Right? SciPy, missing, crawler. Okay, so that was LDA. And then I tried another one, which is a combination of Spacey and Jensen. I had to work around like issues around what Python version I'm running here, what NumPy version, all that fun stuff. You don't want to hear it, but anyway, I was able to install Jensen, an older version of Spacey, otherwise it wouldn't run. And then let's see, so they have a limitizer there, they have a stop words. I'm like, yes, this would be great. An English model, and then you download it, and then you embed your information. Yeah, remove the stop word. This is the default stop word in the English dictionary, right? And then I come with found this document list 0, which is I think the first topic, and you see things like machine learning, Wikipedia, jump content, toggle, sidebar, things like that. And then do I have a? Oh yeah, sorry, this was one of the documents, not one of the topics. This is one of the documents. Let's train the model here. Yeah, the model from Jensen. So this is the topic, and let me understand this a little bit. So this is the topic ID 012, and I think this is some kind of scoring weight, or I don't know how to interpret this. I haven't really used Jensen and Spacey, but I think it's like a weighted scheme with space, the word use, data, datum, Amazon, Kinesis, feature, loads of spaces, AWS. Almost like a regression.
I mean, yeah, you're right. It almost looks like a linear model on these words.
LDI creates a matrix, and it looks for something like eigenvalues.
Yeah.
It's not exactly eigenvalues because the matrix is not square,
Okay.
but it is some kind of generalization of the eigenvectors, eigenvalues computations. And well, yeah, so it computes them, and then you can see them, and basically what has the highest frequency to appear.
Okay. Yeah, so this is one. Another one is similar to the other one. It just towards the end it changes towards SageMaker training model. Okay.
I find it interesting those somewhat large weights given to long spaces.
Right.
So
Right. Yeah.
probably clustering these topics based on different sources that tend to have different amounts of spaces embedded in their web content.
Mm-hmm. Yeah.
Maybe.
How close they are visually even. Yeah, but some of them make sense, like especially this one, like face, class, image recognition, facial, video detect, PySpark. Like they all like this is a very good representation of a topic to me. Like and you can find sample documents related to topic 4 very easy. So if you do a search for, let's say, detection or face detection, you should definitely find topics or documents close to the topic 4 cluster.
You can drop, lengths of spaces using regular expression. I actually have a script which I keep
Yeah.
for text pre-processing, and I modify it when I need to use it.
So yeah, this is, you can definitely do a lot of things. This is me. What do I do 2-3 days before my presentation?
Oh, okay. Yeah.
With minimum data preparation. But yeah, if I wanted to, yeah, definitely stop words, definitely, spaces and all that. So I see some good progress here. It's just that it needs a little bit of data preparation. So that's, to me, always a lesson,
You had stop words with the second method too, by the way. If you look up how you did it.
Yeah, so this should be the stop words that are common in the English dictionary. Yeah, so I guess multiple spaces don't count. I don't know. I need to look at the definition of yeah, remove stop words. Cool. The other approach I would do is, then I was looking, okay, do I not have enough data, or probably do I not have good data engineering or feature engineering? Probably, like I didn't do a lot of pre-processing. Then I was Googling, like, how many documents do you need to actually do a decent job in topic modeling? And Amazon Comprehend, which does topic modeling, says you need at least 1,000 documents in each topic modeling job, which sounds like a lot to me, right? Each document should be at least 3 sentences long. And if a document has mostly data, you should remove it. So this is more on the comprehend side. Let's see what other resources I found.
That's interesting. 1,000 documents, at least 3 sentences long. You've got far fewer documents, but generally they're a lot longer than 3
Right.
sentences. Would it make sense to slice them up and label them in a way, and then try to train with more documents?
Right. Yeah. Yeah. Plus, I don't know what comprehend uses under the hood, right? So
It's LDA.
LDA. Okay.
Yeah.
Okay. That was one approach. The other approach would be for things like this, or where HTML basically dominates the scene. I was thinking maybe I give a link of URLs. You pass them through. You treat this as a computer vision task. You read this and you try to extract the text out of it, because really all I want is what I see as a user, right? Not what the web sees or the computer sees.
Yeah, not what your browser sees, but what you see. Yeah.
Right, exactly. So what does the user see? So I'm interested in models, machine learning, model validation, underfitting, random forest. I'm not interested in this. What is this percentage font? All the fun stuff. So you pass it to computer vision, then you pass it through extract, right? You want to extract the different keywords, and that becomes your corpus. And then maybe you can do your LDA and other techniques.
Spacey can drop HTML tags. It can drop numbers and something else. I don't remember.
Okay.
But it's very good for cleaning. My students loved it. Linguistic students.
Well, maybe, yeah, I need to take a close look at the spacing and see how do I remove the rest of the, tags and things like that.
It takes time and it is heavy.
Yeah, yeah. Again, this is out of the box, doing a little bit of Google search, experimenting. So minimum, a couple of days of effort on mine. Like, it's not something I would,
One of our friend Elsa, if I'm not mistaken, is I believe she's an expert in this. Like, this is part of what she does for a living.
Okay.
Yeah, she's very. I know in the past she's been very involved with topic modeling.
Yeah.
So yeah, she'd be a good person to bounce some things off.
Yeah. And again, this modular approach here, I find it interesting. Documentation seems really good, and I like from that approach, you know, like the visualization as well. Really, what I was thinking is, I have this many bookmarks. Can you identify the clusters for me? Can you identify, oh, there's Amazon, there is Kinesis, there is you know, S3, there's SageMaker, there's hyperparameter tuning, like whatever I was trying to do with my bookmarks here, these clusters. Can you identify them for me? That's the end goal. And all right, so that's it for this step 3 out of 3. We learned a lot, really rewarding in and out of AWS. Post the recording here if you want to look at the rest of the sessions we did, and then we're going to switch gears to something else. Continue our adventures. All right, I'll stop sharing at this point. And, just want to thank everyone for participating.
Thanks. Topics were quite fascinating.
Thank you. I'm glad you liked them. Thank you for your input. Cool. Thanks, everyone. Hope you have a good evening, and we'll see you next time. Stop recording.
See you next time.